Okay, so today we're doing circumference of a circle, but we're working on harder examples. So a lot of these involve word problems. So let's have a look at this first one. It says Tim's bike has wheels with a diameter of 60 centimetres. How far does the bike move when a wheel turns around once? Okay, so what happens when we turn a wheel is that this point, let's just say this point here, which is connecting with the road, has spun all the way around when you pedal your pedals, when you push the pedals, goes all the way around to there. Now, how far do you actually move when that's rotating around once? Well, you move from where it is here to here. And that distance is exactly the same as the circumference of the wheel. Okay, so it actually unravels. I'll show you. So if we have a look at a piece of paper here that I'm just going to fold up into a circle, and you'll see what I mean. So here's your wheel, right? So there's a circular wheel. Now, as it actually goes around, all right, so as it spins around, what happens where my fingers are, when it spins around like that for one rotation, if I unravel it, that distance there was the circumference of the circle when I had it folded up around. Okay, so it was the circumference, then it unravels and it's straight along that line there. Okay, so that's what I've drawn on the board there. So for us to find how far you went in one rotation or one turn of the wheel, we need to find the circumference of the circle. Now they've given you the diameter of the circle here, so we're going to use the formula with the d in it. So it's c equals pi d. So if we sub in pi times our diameter, which is 60, and now we just go to our calculator and we're going to type that in. So it's pi times 60 that we're typing in the calculator. So let's see what we get. All right, so we're doing shift pi, we know where that is now, times 60 equals, and we write all of that down. And we write centimetres on the end. Now, I don't like doing any rounding unless the question asks. So this one just says how far, it doesn't ask for any rounding, so we're just going to leave that answer like that. All right, now, in the second part of the question, it says, if Tim cycles 900 metres to school, how many complete turns does the bike wheel have to take to get him there? So we have to take the 900 metres and we need to divide by, we want to know how many of these distances, which were one turn of the wheel, will get us there. So I'm going to copy that number that we just found in here. But the only problem is that's in centimetres and this is in metres. You must have everything in the same units. So I'm going to leave the 900 metres, but I'm going to convert the centimetres into metres. So because I'm going to a bigger unit, I'm dividing by 100 for centi. So if I just do this number divided by 100 on the calculator, I'm going to get this answer. Okay, so now I'm going to press that into my calculator. So I'm doing, you can put this in as a fraction, just like that. So just press the fraction key, 900 on the top, down arrow, and we're going to do 1.8849555592 on the bottom, just like that, and then press equals, and that's the answer we have. So we're going to write that down. And that's how many turns that we're going to be doing to get ourselves to school for 900 metres. Now, it says how many complete turns does the wheel make. Now, he actually has to get to school, all right? So, are we going to say 477 turns, or are we going to say 478? This question is a little bit ambiguous the way they've asked this. So, I can understand that some of you will think 477, and some of you will think 478. It's difficult to know exactly what they're trying to get here. All right, if we did 477 turns, you'd be just slightly short of school, but they're the whole number of turns that we've done. Okay, if you do an extra turn, well, I guess you're a little bit past school. So it's a bit of a strange question that they've asked this on. They should have just left it at that. I would have been happier just giving that answer there and not asking for the number of complete turns. But I think they're probably wanting that because that's the whole number part of this. Okay, so that's probably what they want. Okay, now in question 2, it says a 20-cent coin has a radius of 16 millimetres. Calculate its circumference. Because we've been given a radius, I'm writing that formula down. So now we're just going to put in our radius, which is 16. The reason I'm giving you this as something that's supposedly a harder question when it's not really that hard is because they've thrown an extra number in here with the 20 cents. But that's got nothing to do with it. Really, it's just a circle. They could have just said a coin, and it wouldn't have looked so confusing. But because we've got a couple of numbers floating around, it looks a bit tricky. Okay, but the radius is 16. That's all you need to put in. So you go to your calculator. You know what to do now. Press 2 times Shift Pi. Don't forget where that is. Shift Pi times 16. And you will get equals, write it down. Now this one does not ask for any rounding, so I'm just going to write millimetres on the end and leave it at that. They don't ask for rounding, I'm not giving any, just like I didn't give any over there. All right, so in question 3, we're looking at a tin of tomatoes. Has a diameter, let's move this a bit closer, has a diameter of 75 millimetres. If the label wraps around the tin completely, that means with no overlap, how long is the label? Okay, so you've got to think about what happens when you're actually looking at a tin. So the label around the can looks like this. It wraps around the tin. So that's the label, okay? This is the top of the tin. It's a circle on the top, okay? So it looks like that. That's the top. And it says that it's got a diameter. This tin has a diameter of 75 millimetres. Now, if we unwrap the label, we want to know how long is the label, right? So remember what we did before with the wheel? So if we take this and unwrap it, we want to know how long is that label. Well, where did this come from? It did come from the circumference of the circle. So we know that that circumference unwraps to become that length. So those two red things are the same. So to get the length of the label, we need to get the circumference of the circle. So we're going to use pi d because they've given us a diameter this time. And we're going to put that diameter in. And let's put that in the calculator. So you know what to do. You press Shift Pi times 75 and press equals. And just write down what it gives you, the whole thing. And that's in millimetres, and they want to the nearest millimetre. So the nearest millimetre will be the nearest whole number. So we're drawing our line there and looking at our next digit. So this is a 5 or more. That means this goes up by 1 to become a 6. And that's your final answer. Okay, so let's look at the next question. All right, the next one says, the International Space Station completes one circular orbit of Earth at a height of 400 kilometres. That's a height above the Earth's surface of 400 kilometres. If the radius of the Earth is 6,400 kilometres, find the distance travelled by the space station. So, when we draw our diagram for this, I've started to draw it. Here's Earth. It's a sphere, right? So we're just looking at a circular cross-section of our sphere. They told us that the radius of the Earth is 6,400 kilometres. Okay, so I've marked in the 6,400 kilometre radius for the Earth. Now, they told us the International Space Station, which I've called ISS for abbreviation, is 400 kilometres above the Earth. So, that means that this distance from here to here is 400 kilometres. So it's above the surface of the Earth. Alright, so they want to know how far, find the distance travelled by the space station. Well, this is what the space station's doing. It's out here orbiting the Earth. It's going all the way around the Earth in a circle. So we want to know how far it's travelled. So all the way around is the circumference. So we're going to do c equals 2 pi r, because you can see we're dealing with radiuses here. So now we're going to sub in. Now this is the tricky bit. What's the radius of the circle that the space station is orbiting on? Now the radius is this whole thing here, from here to here. Right? That's the radius. So if we have a look at this whole bit, to get that radius, we would do 6,400 plus 400. And if you add those on your calculator, you're going to get 6,800 for your radius. So I'm going to put that number in here now for the radius of the orbit for the space station. So now you're going to put that in your calculator. So we're typing in 2 times shift pi times 6,800 and press equals and write your answer down. And put kilometres on the end. Now, they have not asked for any rounding here, so we're not giving any. And that's how far the space station goes in one orbit. 42,725.66009 kilometres. Okay, now we're looking at number 5. Now this is a hockey pitch. The tape has to mark out this whole hockey pitch. And we have to find how much tape is being used. So there's a lot of lines here that we've got to all add together to get how much tape's being used. I always start my working with the curves. So I'm going to start by looking for those 2 bits. Okay, now if you can imagine those 2 red parts, if I took them away and joined them together, they would form a whole circle. Because this is a semicircle, this is a semicircle, so really I'm looking at 2 semicircles together. So all I'm doing is finding the circumference of one circle. Okay, now I have a radius of the circle here, so I'm going to use c equals 2 pi r. And then I'm going to put in my radius. Now my radius is here, between the centre and the edge of the circle. So it's 9 that I'm putting in. Okay, so now I'm going to go to the calculator, and I'm not doing any rounding on this at all. So just type it in, 2 times shift pi times 9. And you get 56. Let's write it down. Okay. All right, so that's what we've done so far, just found the circle. Now there's plenty of other bits we need to add on here, so we have to be a little bit careful with what they all are. So let's see if we can do all of it together now. So the tape, well, we need to do this bit, so we're going to write this down again. And what else do we need to add? Okay, well we need to add the length here, 44, and another length up here, 44. So let's write those down. Okay, so we've done this. We've done this one, which is another 44 up here. What else do we need to add? Well, we have to put tape down this line here. That's 22. And it's a good idea to do what I'm doing here and tick them off as we're going. And what else do we need to put tape on? We need to put tape on that line, which is going to be the same as that. So that's going to be another 22. Tick that off. Plus, up here, another 22. And tick that off. Okay, so make sure you tick them off as you're going so you can see that you've done everything. And then we're going to add all of this together. Now, lucky I haven't cleared my screen from before. I've still got my 56.54, that big long decimal there. So I'm just going to do plus 44 plus 44 plus 22 plus 22 plus 22. And I'm going to write my answer down. And there's the answer off the calculator. Now they do ask for rounding here to 1 decimal place. So I'm going to do my rounding. Draw the line after 1 decimal place. The next digit is less than 5. So this is going to stay as a 5. And copy it all down and put metres after it. Okay. And that's the end of that question. So there's a bit involved, but always start with the curves and then you can add all your straight lines on later. All right, now in number 6, it says a circle has a circumference. They've already given you the circumference this time. And we're asked to find the diameter. That's what we're finding. So, because we're looking at the diameter with a d, we're going to put the formula for circumference with the d in it, c equals pi d. Now when you come to sub in, we know that circumference. So we're going to put our circumference in this spot here. Because we know that that's the circumference. Then we're going to copy over here pi times, and we don't know the diameter because that's what we've been asked to find, so we're just going to keep it as a d there. Now, you're finding the diameter. That means you need to get d by itself. So we're solving an equation. That means we need to get rid of times pi. So we go to the other side of the equation and do the opposite, which is divide by pi. So let's write down what we've got. Okay, so now we're going to go to the calculator and we're going to type in a fraction key, 50.625, down arrow, and then we're going to put shift pi down there. So it looks like that, and then press equals and write down what you're getting. Okay, and now the only rounding they're asking for here is correct to the nearest centimetre. Well, this is already in centimetres, so we're just going to the nearest whole number. So if we just draw our line after the whole number and circle our next digit, that's less than 5, so this is going to stay. So your answer is 16 centimetres for your diameter. So that's the end of that, but there's a lot of tricky questions there. Make sure you try these with your homework and make sure you show you're working. Start with your formula that you're using, go from there. Okay, in the next video for today's lesson, I'm going to be starting the easier area of a circle questions.